All right, guys, I want to start off with this mystery over here. We've said that for an atom to have a full outer shell, it should have at most 8 electrons. This is iodine. It only has 7 electrons in the outer shell, so everything seems okay there. But look at the inner shells. Clearly, this inner shell here has way more than 8 electrons. So does this one, for that matter. What in the world is going on? Well, we've talked about s orbitals and p orbitals. As it turns out, by studying some of the other orbitals, we can start to figure out what's really happening over here. The first type of orbital we're going to talk about is the d orbital. Now, we see that there was, at any level, there's one s orbital. At any given level, there can be 3 p orbitals. And at any given level, there can be at most 5 d orbitals. And each of these is a single d orbital. Now, the d orbitals look a lot more complex than the other ones, but still, just like any orbital, a d orbital can hold at most 2 electrons. Now, here's what I want you to pay attention to. See this d orbital here? Even though it has 4 lobes, it is still only one orbital. Therefore, this whole thing can only hold 2 electrons. See this d orbital? Even though it's really weirdly shaped, it's still just one orbital, and it can hold, at most, 2 electrons. Now, all of these d orbitals would be on the same atom. Let's take a look at what happens if we put them all together on the same atom. If we put them all together, you take this type of a d orbital, this type, this type, this type, and this weird looking thing, and put them all in the same atom, you get something that's really complicated to look at. And you're not usually going to see a drawing that's quite this intense, but I want you to get the idea that these all are overlapping each other, creating a very complex model of an atom. But it doesn't stop there. We also have f orbitals, and we see that f orbitals are even more complicated. Now, here's the thing. Even though this f orbital has, for example, 6 lobes, it's still just one orbital. And this whole thing can still only hold up to 2 electrons at most. This f orbital, even though it's really weird and intense looking, is still just one orbital, and it can also hold, at most, 2 electrons. So how do we figure out which orbitals get filled when? I mean, is it just you just go SPDF? No. It's actually a little bit more complicated. By the way, in case you haven't already picked up on the pattern, you get 1 s orbital per level. You get up to 3 p orbitals per level. You get up to 5 d orbitals per level. And you get up to 7 f orbitals per level. And it's not too surprising because it's just going up by the odd numbers. So now we need to think about how do we actually fill in these orbitals. Over here, we've written out that at the first level, in that inner shell, you have at most 1 s orbital. There's no p orbitals at the first level. The second level, you have s orbitals and p orbitals. Then you have s, p, and d. And for everything else, you have s, p, d, and f orbitals. Now, there's nothing past an f orbital that you're ever really going to talk about. So let's take a look at how we actually decide the order that they get filled in. You don't fill it in just like this. You actually have to follow these arrows. Look at how these red arrows are angled. So let's understand what that means. The first 2 electrons go in the 1s orbital. The next 2 go in the 2s orbital. Now remember, there's 3 p orbitals, so you can put up to 6 electrons. Why? Because there are 3 orbitals. Each one can hold up to 2 electrons, and the total number can be up to 6. After 2p, you go to 3s. Then you go to 3p. Then you go to 4s. Then you go to 3d. Now notice, you don't put anything in the 3d orbital until you filled up the 4s orbital. Then 4p, then 5s, then 4d, then 5p, then 6s, then 4f, then 5d, and all this kind of stuff. So this, just go, you should copy this down, memorize this. You're going to be using this a lot. This is how you determine which electrons go where. So now we open this thing by talking about iodine. Let's now look at the actual electronic configuration of iodine. And here it is. Now, we basically follow along the arrows of this previous thing. We follow along this path, and if we do that, we get the following electronic configuration. This is read out loud as 1s2, and it looks like a squared, but we call this 1s2. Then we say 2s2, 2p6. And if we follow those arrows, we're going to get this stuff. Now notice the last orbital is not full. It's not 6, it's 5. And that makes sense because iodine doesn't have a full outer shell. How many electrons does it have in its outer shell? Well, look at all the 5s. You have 5 electrons in the p orbital, 2 electrons in the 5s orbital, so a total of 7 electrons in the outermost shell. You have in the 4 level, you have 10 d orbitals, 10 d electrons, 6 p electrons, and 2 s electrons. So there's 18 electrons in the shell right below the valence shell. So this is what the electronic configuration of iodine looks like. And as we get more and more into depth in depth with these, you're going to see how this affects the structure and behavior of different elements.